Hi everyone, in today's tutorial, we want to solve this Math Olympiad question. This Math Olympiad question is asking us to solve for the values of a, b, and c, where a, b, and c are integers. Now the question says, ab plus c is equal to 2020, a plus bc is equal to 2021 to find the solution, to find the values of a, b, and c. Alright? Please watch the solution from the beginning to the end because interesting insights will be brought in. Every step will be well explained. We'll try to bring the simplest possible solution that we can. It will be very interesting, I promise you. All right, let's start. AB plus C is equal to 2020. A plus BC is equal to 2021. On the left hand side, we have A, B, C, A, B, C. Now, you see, it is not arranged in a uniform manner, but if we call this one equation 1, call this one equation 2, but if we look at it carefully, we will see that we can carry out some algebraic manipulation so as to obtain an expression on the left-hand side, which can be factorized. The best algebraic manipulation will be, since this number here is greater than that number, it will be to say equation 2 minus equation 1. Okay, let's carry out that exercise. This 2021 is bigger than 2020, so we'll say equation 2 minus equation 1 and see what we obtain on the left hand side. We'll definitely obtain an expression which is factorizable. Let's go. So we have a minus ab, and then plus bc minus c is equal to 2021 minus 2020, which is 1. Okay, now if we look at this first two expression, a is common, the second two expression, c is common. So let's go ahead and factorize out. We'll factorize out a here. We're going to have a into 1 minus b. All right, in the second expression, c is common. If we factorize out c, we're going to have c into b minus 1 is equal to 1. This is what we obtain. Now we have here 1 minus b minus 1. We all know that algebraic manipulation that we can do to obtain b minus 1 here. We want to have b minus 1 common. Okay, we know that b minus 1 is the same as negative into 1 minus b. All right, let's check it out. Let's open this parenthesis and see if we get this left hand side. Negative multiplied to 1 is negative 1. Negative multiplied to negative b is positive b. So b minus 1 is the same as negative into 1 minus b. Okay, also we know that 1 minus b is the same as negative into b minus 1. If you carry out the same check, you will see negative multiplied to b is negative b, negative multiplied to negative 1 is positive 1. All right, we want to have b minus 1 on both sides. All right, we want to have b minus 1 on both sides. So in the place of 1 minus b, we are going to write this. Right, in the place of 1 minus b, this one, you see they are the same. We are going to write this. So we have not changed the equation fundamentally, but it's going to help us in our factorization process because we'll end up having b minus 1 here, b minus 1 there. All right, let's replace this with negative into b minus 1. So we obtain a into negative into b minus 1 plus c into b minus 1 is equal to 1. This is what we get. All right, let's open this parenthesis. We have we have this negative comes out, it becomes negative a into b minus 1 plus c into b minus 1 is equal to 1. Now we have b minus 1 common. There's b minus 1 here, there's b minus 1 here. We still go ahead and factorize out b minus 1. All right, when we remove b minus 1 from here, we have negative a. And when we remove b minus 1 from here, we have positive c. is equal to 1. Okay, so that's what we get. All right, so we have b minus 1 negative a plus c is equal to 1. The left hand side is now a product of two expressions. This expression multiplied to this expression. It would make sense if we also convert this right hand side into a product of two numbers. We all know that 1, the number 1 can be expressed as 1 times 1 in product form. 1 can also be expressed as negative 1 times negative 1. So if we call this A, call this B, well, let's call it, since we have the letters A, B, C there, let's call this X and call this W, for example. Okay, so from what we have here, we can come up with two systems of equations. The first system of equation will go with this product. The second system of equation will go with this product. All right, let's form our two systems of equations. All right, so we form two systems of linear equations. Okay, the first one will go with star. Using star, so we're going to obtain b minus 1 into negative a plus c is equal to 1 times 1. So that gives us, when we match term for term, this first term will go with the first one there, b minus 1 is equal to 1. We call that equation 3, since we already have equation 1 and equation 2. All right, and this negative a plus c can just be written as c minus a. So we'll just say c minus a is equal to 1, equation 4. All right, so this is the first system of equation that we have. The second system of equation will be formed when we use W. Okay, so let us solve this system. We have two simple linear equations in terms of two unknowns. So it is solvable. No, in terms of three unknowns. So, but from equation 1, we can obtain the value of b. B is equal to, take this negative 1 that way, b will be 1 plus 1, which is 2. So the value of b is 2. Then we obtain the value of b. Okay, so we cannot substitute here in equation 4. Yeah, we cannot substitute in equation 4. So but what we need to do is to take this value of b and go to equation 1 and equation 2 and substitute it there. In equation 1 and equation 2, we substitute there, we're going to obtain another system of equation, this time around in terms of a and c, since we know the value of b. So put b equals 2 in equation 1 and equation 2. All right, when we do that, so we'll get what b is 2. So this one becomes 2a plus c is equal to 20. Down here we have a plus 2c is equal to 21. Okay, so here we have two equations with two unknowns. All right, two equations with two unknowns, which is solvable. All right, two equations with two unknowns, which is solvable. So we can call this equation 5, call this equation 6. We have two equations with two unknowns, which is solvable. So let's write the equations again here. We have 2a plus c is equal to 20. That's equation 5. And then we have a plus 2c is equal to 21. Equation 6. Now, if we multiply, if we want to eliminate a, we want to use elimination system. Okay, we want to eliminate c. So let's make the coefficient of c to be of opposite sign but equal. So if we multiply equation 5 by negative 2, for example, all right, so we say negative 2 multiplied to 5. We'll multiply equation 5 by negative 2. So we multiply all three by negative 2, we have negative 4a minus 2c is equal to 20, negative 40, 40. Okay, we can call this one equation 7. Now, look at it now. This is negative 2c, this is positive 2c. So we say equation 6 plus equation 7. So equation 6 plus equation 7. What do we obtain? We're taking this equation and adding it to this equation. So negative 4a plus a is negative 3a. Negative 2c plus 2c is 0. Negative 4040 plus negative 4040 plus 2021. That will give us negative 2019. Negative 2019. All right. Now from here, if we divide both sides by negative 3, we obtain the value of a to be, the value of a will be 673. Okay. That gives us the value of a. The value of a is 673. All right. We know the value of a, we know the value of b. So let's put it somewhere. A is 673, B is 2. Okay, we will need to get the value of C. Now that we know the value of A and B, we'll now put the value of A in C minus A. In C minus A, this one, equation 4. Okay, we'll now put the value of A in equation 4 in order to get the value of C. All right, so put A equals 673 in equation 4. This is equation 4. So we're saying C minus 673 is equal to 1. This therefore means that C will be 673 plus 1, which is 674. Okay, so we now know the value of C as 674. Value of C to be 674. So this gives us, therefore, the first set of solutions for A, B, and C for the system equation 1 and equation 2. Okay, that comes from the first proposal, converting 1 as the product 1 times 1. All right, we also have to check this possibility. So our next system of solutions will come when we consider the next possibility of negative 1 multiplied to negative 1. Let's go ahead and do that. Now, considering W, we're going to have our system again was, considering W, we're going to have 2, we're going to have B minus 1 is equal to minus 1. B minus 1 is equal to minus 1. And we're going to have C minus A to be equal to minus 1. This one will now become equation 8, equation 9. Okay. Now from equation 8, we can get the value of B. All right. From equation 8, we know B is equal to, we take this one this way. We take that minus 1. We take this minus 1, this will become positive 1. So it will become 1 minus 1, which is 0. So the value of B is 0. Okay. We've gotten the value of B to be 0. Now, putting this value of B also in our initial equation, equation 1 and 2, to obtain another set of simultaneous linear equation in terms of A and C. So, putting B equals 0 in equation 1 and equation 2, our original equations, we're going to obtain A multiplied to 0 plus C is equal to 2020. This simply means this is 0. It simply means C is 2020. This has given us the value of C. We've just gotten the value of C. All right. And then we'll also take B equals 0 and put in equation 2. All right. Put in equation 2, we have A plus 0 multiplied to C is equal to 2021, which simply means that the value of A is 2021. Okay, that gives us the value of A as 2021. So we have all our three solutions a lot easier in this second system. A is 2021, B is 0, and C is 2020. All right. So this gives us our possible solutions for the system equation 1 and equation 2.